All right, guys, so we're going to do a little bit of introduction to some circle vocabulary in today's lesson. So there's just some background stuff. Make sure you take these notes carefully. These are some really important vocabulary terms that we're going to need for the rest of this unit. So we're in our circles note packet. I know the page numbers might not match up. We're on the part that says 8.1. I know we're not really in unit 8, but we've kind of been jumping around a little bit. So once you get there, you can get your pencil out, start taking notes. I'm going to ask you to take a picture of the notes you do for the homework tonight in order to get credit. So, circle vocabulary. Basically, the set of all points in a plane that are equidistant from a fixed point called the center is a circle. So what that means, kind of like that's the official definition, but there you go. Fixed distance from the center. So what that tells us, and this is a word we're going to look at that you already know, the fixed distance from a center. So if I have like a piece of rope and I attach it to the center and I pull that rope here 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 all the way around, no matter what direction I go in and I pull that rope tight, it's always going to hit, it's always going to form this circle. Think about a dog on a leash. If it's running around, as far as it can go, it can never go past that length of that circle, that size. All right. So a center segment from the center of the circle to the point on the circle is called a radius. So all those blue lines I drew up there are called a radius, or plural radii. Note that all radii of the same circle are congruent. So something we're going to use going forward, that was a horrible circle. Let's say I have my circle and I draw two radii here and here. Those radii, since they're part of the same circle, have to be congruent. And we're going to come back and start looking at our isosceles triangle rules again. So we're going to keep using triangles to our advantage this unit. Okay, probably a new word. A segment whose endpoints are 2 points on a circle is called a chord. All right, so if it's a segment that goes from one end to another end on your circle, it's called a chord. And a chord that passes exactly through the center of a circle, we know this one, is called a diameter. So I want you to put a star next to this one. This is going to be an important one that we're going to need to keep in mind throughout this unit. All right, so just looking at this vocabulary, MN, segment MN, and I should have put the segment marks up here. Maybe it just didn't come through on your copy. All right, so we're talking about segments here. Segment MN all the way across here. So it goes from one end of the circle to another. So that's a chord. That's an example of a chord. But since it goes exactly through the middle of the circle, since it goes exactly through the middle at O, we also know this is a diameter. Okay, so you can pause the video, fill these in on your own, see how you do, see if you have questions, and then I'll go through them in a second when you're done. So pause now, try those out, make sure you know the vocab. Excuse me while I sneeze. Okay, so hopefully you paused and tried them out. MQ, one end of the circle to another on the circle. So one end of the segment on the circle to another end of the segment on the circle, that's a chord. PO is a radius, center of the circle to the outside. All right, it doesn't go all the way through, that's why it's not a chord. MO is also a radius, so obviously we can have more than one radius in a circle. QN, one end is on the circle, the other end is on the circle, that's another chord. All right, so important vocab for this unit. This is, not that much to it. Exterior is a point outside the circle. Interior is a point inside the circle. Point B is on the circle. That's not super important or super hard. This is what you need to focus on for today. Chord, radius, diameter. Pause if you need to. Next page. A central angle, this is what we're going to be really examining closely next class. A central angle is an angle whose vertex is on the center of the circle. And actually, I just remembered this is actually on the previous page. That's at the bottom here. So you didn't need to flip, I did, but whatever, same thing. An angle whose vertex, there's the vertex right here. An angle whose vertex is exactly on the center of the circle. So in this case, and we're going to go back to really being careful naming our angles, angle BOA is a central angle right here. BOA is a central angle. Its vertex is exactly on the middle. And a little bit of foreshadowing, this arc that it cuts into. So you can see that angle cuts into that purple dashed arc I just made. So if this arc is 80 degrees, not surprisingly, this central angle is also going to be 80 degrees. All right, so keep that in mind. We'll come back to that a lot next time I see you. Speaking of that, an arc, and the symbol for an arc is this. So it's like a segment, but it's just a curved piece. An arc is a continuous portion of a circle consisting of 2 points. So here the endpoints are A and B, and all the points on the circle in between them. So in this example we just looked at, I gave you the measure of arc AB. So arc AB was equal to 80 degrees. All right, so this is probably the most important vocab word we're going to learn this unit is arc. All right, so minor arc. A minor arc is an arc whose points are on or in the interior of a corresponding central angle. Basically, a minor arc is the portion of the circle that the central angle cuts into. So for this example here, right here, AB is your minor arc. So notice how this central angle cuts off, basically, arc AB. So you can see how they both kind of match up. This arc is equal to that angle on the inside. So that's a minor arc. A major arc is the other way around. So same angle, central angle ACB, still cuts into that same arc. But notice how this is named differently. The major arc is kind of the part, well, it's the major part. It's the larger part that's kind of not being cut into. And you can see how this was named really carefully. So if I just said, okay, guys, this goes back to like naming angles. If I said, okay, guys, name arc, or show me arc AB. AB could have been this part here, but it also could have been this part here. So what we do is we throw a third letter in there. All right, so for this example I just did, you can see they put that extra letter, that extra point. So the major arc, arc ADB, is the purple dash line that I just wrote there. So let's say, for example, let's say this is 60 degrees here. That central angle is 60 degrees. That means this arc is also 60 degrees. That tells us this major arc, the rest of it, since we know a circle adds up to 360, we know this major arc would be 300 degrees. Okay, so these are all tools we're going to use coming up the next couple of classes, using our knowledge of circles equal 360, using our knowledge of linear pairs. So that's leading us into our next one. A semicircle is an arc whose endpoints are on the diameter. So there's chord AB, it's also a diameter. And if I look at arc ADB right here, so following along with my pen, arc ADB, since this is exactly half the circle, we know that's going to be equal to 180 degrees. Okay, and this is a really critical thing to look out for, those diameters, okay? So yeah, so naming arcs, seeing arcs, looking at those central angles is going to be a really important thing for next class. Okay, last little bit of vocab, and this is why we're doing it now, to get it out of the way. Each endpoint of the arc lies on different rays of the angle. That's what an intercepted arc is. So again, it's kind of like a formal geometry definition, but it's all about looking at what arc the angle cuts into. So arc BC. So what I like to do, again, is use my little dashed line. If you guys have highlighters, that's really helpful this unit. Arc BC is cut into by angle BOC. So you can see how that angle is slicing into, cutting into arc BC. All right, see if you can do this next one on your own. I'll walk through it too. So arc AB right here. So there's arc AB. Arc AB is being cut into by this angle. So angle AOB. All right, guys, so hopefully you're following me along here. And then last thing, ADC. So naming them in order, ADC. All right, so I'm just going right around the circle. I'm not like zigzagging. I'm not going like this and then cutting off to see the arc. We're tracing our path around the circle. So arc ADC. This is actually one of our really special examples. It's cut into by this full 180 degree straight line. So angle AOC. And what's really important about that is that tells us that this is exactly 180 degrees. All right, guys, that's our job this unit, is to really know how to identify, how to name, how to label. So one more example, let's just look at one together. Let's see, we're gonna name minor arcs, major arcs, or semicircles. So if I look at number 4, for example, arc ACD, arc ACD. Really important. I'm going to get the magic pen out for this because I don't want you to write it. Arc ACD. I don't slice like this. I don't go in a zigzag. I don't go directly from A to C to D. That would be an angle. All right, again, we're looking at arcs. So arc ACD. I'm just going to basically play a game of connect the dots all the way around. There's A to C to D. That's arc ACD. I also could have called it arc ABD, right? As long as we're kind of following in that same order. So arc ACD, arc ABD, either way you think about it, that is a major arc because it's more than 180. It's the bigger part of the circle. All right, does that make sense? Same thing for like number 6. Number 6, arc DEB. Arc DEB is right here. D to E, followed all the way around to B. And you can see for this one, the endpoints of that arc are exactly on the diameter of the circle. It's exactly halfway. So that's another one of our 180 degree relationships that makes DEB a semicircle. Okay, guys, so I hope that makes sense. We're going to do a lot more work with this next time. Let me see how much time we have gone. I don't want to make this go too long for you. All right. Oh, we're done. That was 14 minutes already. Okay, that's it. I'll see you next time. Take a picture of your work. Think about any questions you have, and I will see you next class. Bye.